and I'm going to be talking about artificial intelligence, algorithm, big data, and whether we should be scared about it. And I got the inspiration for this talk because well, my wife, like 99% of the population, doesn't know anything about what I'm doing. They think it's magic. So I want to try to explain it so anyone that is not an IT specialist can understand what it's about and if there are any risks associated to it. So let's start. I need to define some of these terms: algorithm, artificial intelligence, big data. Any of you knows where algorithm comes from? The word algorithm.
Is that Arabic?
Yeah. Do you know when it was invented or how it came?
No.
Actually, it's a guy. It's a mathematician, an Arab mathematician from the 9th century. His name was Al-Khwarizmi. That's where it came from. And actually, I don't know if you've talked to people from Silicon Valley recently. They're really, really worried because they realize that if Trump finds out that it comes from an Arabic word, they might just prevent them from using it. So, I've just explained what I want to talk about and how I'm going to do that. I need to define these terms first, it just makes a bit of sense, and then I'm going to explain how they are used, and so you can understand well the benefits and the risks of them before summarizing and giving my own impression. Mm-hmm. This one is the one that I think I need to explain orally. Basically, an algorithm is a sequence of steps of action that you take to solve a problem. Hopefully it will make sense a bit later. That might be a bit cryptic at this stage, but I'm going to try to explain it. And to explain all of this, I'm going to take a very simple example. You want to calculate the bill in a bar. Okay? This bar sells only beers, and these beers cost €2. Super simple, right? So, I'm going to explain the difference between traditional computing and, all these things. Mm-hmm. In traditional computing, you start with a subject matter expert. You need someone who knows how the real world works. Okay? So this subject matter expert, I'm going to draw him here. Yeah, there's a guy here. He's very good at drinking beers, like all of you here, I'm sure. So he knows, how to calculate the bill, and I'm sure you can help me here. Assuming you have the price for a beer and the number of beer, how do you calculate the bill?
Multiply.
Right. Yeah. So you're a subject matter expert in beer. And basically that's very simplistic, right? But any problem you try to solve with a computer in traditional computing, you need such a guy who understands how the real world works and be able to put something like this together. So, he defines a set of rules of defining the real world, and then you need a second guy who's a developer. Yeah? There's a guy who understands computers and who's able to program them. And so what he's going to do, he's going to take these rules and convert them into an algorithm. So basically, algorithm is kind of the interface between the real world and what the computer understands. It's a sequence of steps that needs to put into the computer solves his issue. And the result is some code, some computing code. And once you've got all these steps performed, you feed your input in the computer. Let's say I'm the bartender, I've got my customers, they've consumed 5 beers, I input my 5, and then I'm going to be using my formula, and it's going to be giving me the price of €10. And that's how traditional computing works. So we've seen that we've used algorithm here. It was just translating the kind of real-world rules into some computer code. Now I'm going to make a small boundary. That's traditional computing. And now let's look at how the world of artificial intelligence and big data works. This time I'm going to need maybe not so much of a subject matter expert, but more of a developer. Because the main difference is what you do, instead of having some great guy defining the rules, you have a computer in which you give a lot of examples, a lot of bills. So you give him a lot of information, and what he's going to do is going to find out by himself this kind of set of rules. So let's say, as an input to this computer, that contains my artificial intelligence, I'm going to give him number of beers and total bill in euro, right? And it's going to be something like 2, and then my bill is going to be 4, and then maybe 5, and 10, blah, blah, blah. And so what he's going to be doing, he's going to be putting that on the plot. Here I have again my number of beers, here I have again my total bill. And he's going to pick, okay, this is 2, this is 5, and then you're going to have some point. Okay, 2 corresponds to a price of 4, and 5 corresponds to a price of 10. So he's going to have a bunch of points like this. And he's going to be trying to do something clever to find out, how should I fit a line? Yeah. So I can use that to actually make further prediction. Once I've got this line, I know that if I've got 1 beer, then my price is going to be here. And if I've got 10 beers, my price is going to be here. I read it here. So basically, this is the same thing to that, except that here you have a human defining it in the traditional computing case. But in that case, you actually have the computer finding out by itself. That's the main difference. So this guy here, maybe what he does actually is provide you some examples. Maybe he's a bartender, he's got some beers, he's able to give you some beers. But then the developer, what he does is actually choose the right algorithm, the right artificial intelligence algorithm that will be able to deduce how to calculate the number of beers. And then the next step is similar, it translates into some code, and you can run, if you're the bartender, your input and you can get your output. Yeah? So hopefully that makes sense, and the idea is, in one case you had some guy understanding the reward and defining how it works, in the other case you just had one computer finding out for instance. And that's the main difference between traditional computing and the world of artificial intelligence we live in. And where big data fits here in the picture, big data fits here actually. So artificial intelligence can work, you actually need a lot of data. And without this lot of data, you can't get this to work. Right. So hopefully that makes sense. And now what I want to move on is give a few examples of real life and why this is used. So let me give you one example, which is recommendation systems. You've all heard of Netflix. So in Netflix, people go and watch movies and rate movies. And so what it does actually, because it's got a huge base of customers and samples of what movies they liked or not, it can actually use that data to deduce what other users will know or like potentially. Yeah? So this is again big data. And that's pretty cool because it's accurate actually. It's able to predict movies that I will like and it works very well. Now that's the upside of it. Downside, if you think about it, you've got all these loyalty cards, and maybe you've heard this story of the father of a teenage girl of 16 in the UK who received some coupons for diapers. He went to the supermarket and complained and said, hey, why are you sending this to my 16 years old? And actually it turned out she was pregnant and she had made some purchase which matched other purchases of pregnant women, which were also buying diapers, right? So they managed to guess that she was pregnant. So the big data, you have to know that they know maybe a lot more about you than you think. So you need to be aware of that. Another example is image recognition. So Facebook, for instance, does it very well. When you add pictures, it's going to be recognizing your friends and help you tag them, yeah? Which is really cool because then this way you can easily find pictures with this friend of yours without having to tag them manually. Now there was a case not so long ago when there was this algorithm of image classification which actually flagged the black guy as a gorilla, right? Which is not something you want to happen because that's very offending. So it's again something you need to be careful about with this kind of AI and big data. Obviously a guy, if he had designed the rule, would never have said, flag this guy as a gorilla, but the computer doesn't know, so potentially that's kind of a mistake you can make. Another example is self-driving cars. So self-driving cars, they work like this pretty much. You know, you gave them hours and hours of recordings of all the features in the car, how the brake was used and how the wheel was steered, and then picture of the road and these kind of things. It learns driving by itself. And you think about it, it's cool because potentially you can just lay back in your car and tell it to drive 500 miles away and be relaxed. Now I heard a very interesting talk on the radio. There was a car manufacturer and he was asked, so what does a car do in the case potentially the life of the driver is at risk, but also you've got, it has to choose between killing the driver or the passenger of the cars and people on the road. And he made all his possible, he avoided the question, he said that's not going to happen, right? But the truth is, it will happen and the car has to make a decision. And if I potentially, program the car or make sure artificial intelligence by default will probably try to save the people in the car. I'm not saying that's bad or good because maybe if I'm the driver, I'm also going to protect myself, and maybe I will run over the old lady or the small child. But I'm making a decision as a human, whereas the car, you don't know exactly what it will do in which circumstances. So it means that there are some decisions that we will now rely on the computer to make and that we won't be making ourselves, and that can be worrying. So that's something we need to take into account. So I've defined basically, what is big data, AI, algorithm, how it works. I've defined a few examples, and now just moving to the conclusion. What I think is that when you talk about artificial intelligence and big data, a lot of people either they love it because it's brought all these cool applications that I mentioned, or they're really really worried because they think of Terminator and they think, there's going to be a super artificial intelligence machine that will take over the world and make humans a slave. And indeed, there are people who are worried about that. So there are some in Silicon Valley, there are people who have some think tanks and thinking about how to avoid that. But that's really very far in the future, according to me. Today, artificial intelligence is not that intelligent, so it's able to do things if you tell it explicitly that it has to do things, but it doesn't learn by itself. It doesn't have a will on itself, right? So it's very specialized in some areas. So unless we program an AI to rule the world, I don't think it's going to rule the world. And even if we wanted to, we wouldn't be able to today. I think that there's two major risks that come from AI and big data. One is privacy. So the big data world, I think, we leave a lot of trace. We all use computers, but we don't necessarily do it in a proper way. And sometimes we know we leave some information, but we don't always know how much information we leave. There's this Clue application we discussed a bit earlier, where women track their menstrual cycle. And in fact, what they track is when they have their cycle and maybe changes of mood or things like that in the application. And they think it helps people know when they're going to have the next menstruation. But actually, they don't realize that they leave more information sometimes when they access the app, because when they come close to the end of the cycle and they start frantically checking every hour, when their cycle is coming up, then you can guess that from how often they access. Maybe they're worried because they had intercourse without protection, right? So maybe they're pregnant. And so they don't realize that because that's kind of information that's being captured as well. They think they just leave information about dates, but actually they leave much more information than they think. So I think we leave more information than we think. And a lot of people say, well, I don't have, I have nothing to hide. But actually, you don't want also necessarily, that's not because you have nothing to hide that you want people to know so much about your life. Think about, how much information Google has about you, and what if US government takes control about it, and what can they do about it? We can move, it's not going to be Terminator, it's going to be 1984, like Big Brother, so that's more the risk I see. And there's a second risk, which I think is very important and coming up very soon, which is the loss of jobs, because we're going to be able to automate a lot of jobs. People don't necessarily realize it, but anything that takes you less than 1 second to think, you can make it with a computer already. So some reports say between 30 and 60% of jobs are at stake. And that's quite a lot. I mean, if you get so many people unemployed, then you're going to have a big problem in the future. So I think that's kind of thing that governments need to think about. How do we deal with this massive potential loss of jobs? So that's to deal with the risk associated with AI, and the other main risk is big data. I think people need education. So today, pretty much everybody gets computers. You're being given the software, the hardware, but not giving the education how to use it. And I think that's key. That's something that needs to be included into the curriculum that every children should be learning. And even adults, actually. So it's a bit of a pessimistic view. I think there are some pluses, but there are also some very big risks, and we should not deny it, especially as data scientists. So we should be aware about it and not hide it, not conceal it, and see what we can do to resolve these issues, because we're going to be part of it as well. Maybe someday people will hate us for what we've done.
I thought about it.
Thank you.